Hi everybody, this is my very first video showing how to blend two different curvature surface in a parametric mode using Siemens NX in this case. First of all, I have already designed two different surfaces. As you can see, the blue one is completely flat and the green one has a little curvature right here. So basically, to define it sketch, very simple sketch and two extrusions. This one, the green one, looks like a double surface, but it's just a double face because um, the sketch was composed by two different curves, the straight one and an arc completely tangent to the very first line. Now, second step is to design a support surface, and in this case I gave a parameter right here. There's an angle that actually show the distance, radial distance between the vertical axis. So that's the axis. In this case, I get started with an angle of 30 degrees, but it will be parametric adjustable, so we can absolutely change the shape in a parametric mode. Let's go ahead. After the support surface, I'm going to split the blue surface in two different spaces, just to be consistent with the green one. So briefly, I had added isoparametrical curve in the point right here where this edge intersects the blue surface, sorry. So let's split in two faces. Now we have two different faces, and go ahead. Now the third step is to trim a little bit and clean the overall surface. Now we need two different blending right here. Maybe we can use the same radius or different radius for the top one and another for the bottom one, but I prefer to stay to keep them equal, so it will be very easy to understand the flows of the curves right here. So I designed using the static phase band. Let's go open the feature. So I used linear continuity for the a different radius, so a variable radius. So at the start we have a 0.3 millimeter radius, and at the end 0.8, and I give a G3 continuity with this phase, and G1 and this one. This is a G1 because it's completely flat. In this case, even this is completely flat, but I prefer to show the setting of the continuity right here in the aesthetic phase blend feature. The same, exactly the same for the green surface. So the yellow is absolutely an aesthetic phase blend. Second feature, same parameter, 0.3 at the end, at the start, and 0.8 at the end. Now, what I'm going to do here, I create a point, exactly an intersection point between this edge of the red blending phase and this edge of the yellow one. So at the intersection, I added a point exactly right here. So what's the purpose of this point? Is having a parametric point where to link an isoparametric curve later. But I added two other points right here in this intersection and this intersection. So basically, the intersection between the edge of the red surface radius blend of this one with the edge of the splitted surface. The same point for the other side. Let's create the isoparametric curve linked to the point previous created, exactly for this surface and for the red one. I can use this to trim a little bit out and reduce the surface unneeded. Now let's move forward and create a perfect blending on class A surfacing till the end. So briefly, we designed at the very start of the project. This is our flat line. So it's basically it's a basic design. Okay, maybe it could be absolutely curved, but as long as we have tangency between the two surfaces, we can make something aesthetically pleasant. So let's move forward and create other parametric, isoparametric curves, absolutely here and here, using the point created at the intersection between the edge of the splitted surface and the point and sorry, the edge of the phase blend, the radius blend. Let's move forward and create a couple of composite curves right here. So briefly, I add underline it. I extract two curves on that these edges, and now I'm going to, and I splitted them using the point previously created. Okay, right now I'm going to add bridge curves. This one I don't need the a G2 or G3 continuity right here, because the only continuity I can add right here is a G1, because I need that the curve, the bridge curve, was constrained to the surface. So if I remove, for example, I want to give a G2 in this curve, maybe, sorry, and G2 right here. It seems to oh, sorry, maybe it's a little bug, but I don't need the G2 absolutely. The G1X works very well right here. Don't know why I should investigate why I can have this curvature continuity. At the first time, it's not possible using G2, but I will investigate it. And so exactly the same kind of curve for the yellow surface and constrained to the green surface. Of course, I have a G1 continuity between this line and this, exactly like the previous one. Let's hide this one. I don't need it. Okay, as a support for the new surface I'm gonna add right now in a few minutes. I create another bridge curves, this time connected to this, the other edge of the red surface, and take attention, pay a little bit attention, not to the center of the middle line, but to the external one, okay, on the right side. So we are connecting the red surface to this one, so to the external one. Now, for this curve, I used the G3 continuity, so it pretty much flowing exactly smooth, perfectly smooth. Now I'm going to add a mesh curve, a surface based on mesh. I used, of course, the 4H and different continuity. The G1 continuity is pretty much enough for this application. So all the edges have G1 except the last bridge curve suspended in the absolutely not constrained to another surface, but I really don't need this. It's just for construction, so G0 is pretty good. It works pretty fine. Let's go ahead, creating a new bridge curve. This new bridge curve, this time I use G1 as exactly like the others, but this time I constrained this bridge curve to the mesh surface previously created. Okay, so the select face, the constrained face, sorry, is exactly the two curve mesh surface. And now I create another through curve mesh, this time using the yellow edge, yellow surface edge, the green surface edge, sorry, um, mm, the bridge curve constrained to the green surface, and the other edge right here, perpendicular edge. As before, G1 tangent curvature continuity is pretty much an simple construction and both emphasis. This is my personal settings I used to to select for this application. Right here, let's go and let's trim all the excess exceeding surface. Okay, and let's join so every surface together. Okay, we don't have any errors or any advising except right here. Number of loops, okay, it's not a problem. One or more boundary, okay, it's not a problem at all. So let's go to hide hide. I want to analyze the surface already created, and before using zebra, I'm going to using zebra right now, and let's take a look on the continuity. It's pretty good. The continuity is pretty good. It's pretty good, pretty good, absolutely good. Let's remove age, and we can see that the zebra analysis works pretty much fine, and we have a perfect G class A continuity and a smooth surface blended very well. Let's try to adapt parametrically the angle of the super surface. Sorry. Oh, let's go. Okay. Let's go to. Okay. We have a 30-degree angle right here. What happened? Oh, it's okay. Okay. Let's try to reduce. Make a 10. Maybe a little bit. And let's see what happened. Curve continuity, it's pretty fine. work pretty well, and the surface is absolutely smooth. Let's try to use another analysis. We can use a different reflection here, or maybe using a different color. Now I want to try an image directly. Let's go to try this image. Something good. No, maybe this one or this. Let's go. Show how what happened. Okay. Okay. It seems to be pretty smooth and flowing well. Exception right here, maybe it could be a little bit um, restored right here with a redefining the tension of the bridge curve in this zone, but it's pretty fine right here. And thank you for watching.